How's it? Hello, good evening, good morning, good afternoon, wherever you are. Just want to say welcome. Yeah, it's been a while, but I'm excited to be back. So today we are solving differential equations. More specifically, dealing with particular integrals. So yeah, let's get straight into it. Let's bring this down. Okay. So I'm first going to divide by d squared plus 2d plus 2 to get y by itself. So then we get y is equal to 1 over d squared plus 2d plus 2 multiplied by cosine t. Now I want to change cos t into another form. So, and we know the identity e to the it is equal to cos t plus I sine t. So to switch this part, this will just be the real part of e to the it. So if we want to switch it, we say it's going to be equal to the real part, which is very important, of 1 over d squared plus 2d plus 2 times e to the it. Alright, okay, so for now what we're going to do is we are going to bring the e to the it to the front. So we have e to the it multiplied by 1 over d squared plus 2d plus 2 multiplied by 1, obviously. Don't forget the 1. So yeah, sorted. So for the d operator method, you're going to look at your exponents. So if it's e to the 2t or e to the it or e to the 5t, whatever is the exponent, so before the t in the sense, you're going to sub it into your denominator as long as your denominator doesn't equal 0. But in this case, we are allowed to. But let's say if this denominator, this was like maybe 5 and we subbed it in and it gave us 0, we wouldn't be able to use this method. But for this case, we are able to. So let's get cracking. So it's going to be e to the it times 1 over, and it's going to be I squared plus 2 times I plus 2 times 1. Okay, and let's just simplify e to the it. It's going to be 1 negative 1 plus 2i plus 2 divided by 1, and this is just going to be e to the it times 1. This is going to be 1 plus 2i times by 1. Right, I know some of you are thinking, what can we do here? But I'm sure you've seen, if dealing with complex numbers, conjugates. So what we are going to do is to flip, basically change this fraction. So I'm just going to multiply by the conjugates. So we have 1 plus 2i. So the conjugate will just be 1 minus 2i. Just flip the sign for your complex number. 1 minus 2i. It's going to be times 1. So we have 1 minus 2i. It's going to be e to the it. 1 minus 2i, and then we have 1 minus 2i plus 2i, and then that's going to be negative 4i squared, which is going to be plus 4 times 1 equals the real part it 1 minus 2i. So these will cancel out, so we have 5 by 1. Okay, looking good, looking good, looking good, looking good. So now what I'm going to do is you can multiply the 1 throughout, which will just give, let's write it here, which will just give us e to the it times 1 minus 2I over 4. Okay, yeah. And then now what I'm going to do is I'm going to convert the e to the it. Remember how we said here e to the it is equal to cos t plus I sin t? We're going to do it here again. So we're going to have cos t plus I sin t multiplied by 1 minus 2I over 5. Okay, that's just going to be equal to the real part. We have, let's say, cos t 1 minus 2I over 5 plus I sin t 1 minus 2I over 5. Right, let's close these brackets here. And then multiplying throughout again, we have, will just be cos t over 5 minus 2I cos t over 5. And this would be plus I sin t over 5. And this will be plus 2 sin t over 5. Okay, now we've done everything we can, we've simplified everything we can. Now we just need to look at what we have here. So we only want the real part of this answer. The real part means that there's no imaginary. So boom, unlucky. Unlucky. So only look at the real parts. We'll have cos t over 5 plus 2 sin t over 5. And that is our answer. 10 marks, 5 marks, 15 marks, we take them. Easy as they come. Yeah, hopefully you found this video beneficial. Yeah, if you have any questions, please put them in the comments. If you have any video suggestions, please let me know as well. And yeah, if you can subscribe and like this video, greatly appreciate it. It really helps a lot. Cheers. See you soon and stay safe.